Each day during this time, we'll be doing some very quick AP review lessons. If you need more about any of these topics, the videos from the previous chapters are still available on the YouTube channel, so you can still see any old videos. But these are just meant as a quick reminder of each of these topics. Today we're going to look at limits and continuity and also differentiability. The practice today is multiple choice questions, non-calculator. For these questions, you'll get 2 minutes per question on your AP test. On the day of your AP test, this is your first section, and you will have 30 questions, and you will be given 60 minutes. For your practice today, you will have 15 questions and 30 minutes. Just a reminder about limits and L'Hopital. Limits are as x gets closer to some value, your y coordinate gets closer to L. When your limit is approaching a number, then the things you should try first are you should try substitution. It might be that plugging x equal a into your function gives you an answer, in which case you have your limit, that's your answer. If it doesn't work, you might wind up, when you do that with 0 over some number. 0 over some number means that your limit is 0. You might wind up with some number over 0, in which case your limit is either positive infinity or negative infinity. And in other words, your limit doesn't exactly exist. But you might get an indeterminate form. If you get an indeterminate form, you might get 0 over 0, or you might get infinity over infinity. And if that happens, then you can do L'Hopital's rule. L'Hopital's rule says that you can take if you have this limit, you have a limit of some function over another function, and that limit is 0 over 0 or infinity over infinity, then you can take the derivative of each of those two functions separately and evaluate those. So you can say, well, I'm just going to take the derivative of f and I'm going to take the derivative of g, not doing quotient rule, but just taking those derivatives separately. And you can then maybe evaluate your limit using L'Hopital's rule. An example of L'Hopital's rule is, let's say you have x squared minus 9 over x squared plus 6x plus 9, and you're doing a limit as x goes to -3. When I plug in -3 here, I get 9 minus 9, which is 0. I get 9 plus -18 plus 9, which is 0. So I can do L'Hopital's rule. I do L'Hopital's rule, and I get 2x over 2x plus 6. Now I can plug in my -3, and I get -6 over -6 plus 6, which is 0. So I wind up not with an indeterminate form, but with a number over 0. So that means that my limit is some kind of infinity. And in order to decide what kind of infinity, I would pick a number that's a little bit smaller than -3, and I would say, oh, that would be negative, and a little bit smaller than -3, so would my denominator, and then I choose something a bigger than -3, and that would still be negative, but my denominator would be positive. So actually this limit does not exist because the two kinds of infinity don't match. But the really big thing is being able to do substitution if that's possible, and then being able to do L'Hopital's rule if substitution doesn't work. The other thing about limits is we looked at graphs of functions and we said, well, a function is continuous if I can draw it without lifting up my pencil. But if I have to lift up my pencil, either because there's a hole in my function, or maybe because there's a jump in my function, or maybe because I have a vertical asymptote, then my function is not continuous. And so continuity says if the limit as x approaches a number from the left, or from the right, sorry, is equal to the limit as x approaches a number from the left, and if the limit is also equal to the value of the function, then my function is continuous. So for example, at this hole, the limit from the positive direction and from the negative direction are both the same, but the value of the function is something different. So I'm not continuous at that point. At the jump discontinuity, I have the limit from this direction and the limit from this direction don't match. So I don't have continuity at that jump discontinuity. And also here, these two limits are both negative infinity, but they don't approach a number. There is no value of the function at that point. So in order for continuity, if you need to prove continuity, you look at the limits from both directions and you look at the value of the function and make sure they're equal. For differentiability, it's almost the same thing, except you want to make sure your function is differentiable at x equals a by checking to see if it's continuous and that its derivative is continuous at x equals a. So for example, this function, let's say x to the 1/3, is continuous at x equals 0 because I can plug in 0 and I do the limit as x approaches 0. I get 0 from both directions, and so it is continuous. But if I take a derivative of this function, I get 1/3 x to the negative 2/3, which if I rewrite that a little bit, I get 1/3 cube root of x squared, and that is not continuous. The derivative is not continuous at x equals 0, so it is not differentiable at x equals 0. F is not differentiable because f prime is not continuous at x equals 0. We can do the same thing with piecewise functions. We look to see if piecewise functions are continuous and differentiable where they join. We want to make sure that the derivative is also continuous for a piecewise function. Right? So those are some big ideas from chapter 1 and 2. Thank you.